All right, so now if we start breaking down these sine and cosine curves a little bit more, we'll see that we can get a generalized format and alter them in pretty predictable ways. So the first thing we're going to look at is the amplitude and the period. So we're looking at two components. One of them, the first one though we're going to look at is the amplitude. So if we generalize the form of sine and cosine by adding in some variables, we would get the following. So we got y equals d plus a times the sine of bx minus c, and very similar for cosine, y equals d plus a cosine bx minus c. So now, again, let's start looking at just what happens when we look at the variable a, none of the other variables. So to give a specific example, if we look at our standard sine curve and then we look at this altered one with the 3 in front, what's the difference? So let's just look at our 5 key points and see what happens. So now if we have 1 and -1, so sine normally would go like this, and I'm being lazy and not writing in my x values. So again, labeling is very important in my class, as you should know by now. So don't forget to label stuff. Okay, so there's our standard sine curve. So what happens when we put a 3 in front of it? Now you probably already know this, but let's just look at our 5 key points. So again, the y value here was 0, so if we multiply it by 3, which is really all that it's doing here, then that doesn't change. So we're still starting at the origin. But when we look at pi over 2, now that y value gets multiplied by 3. So instead of being at 1, it goes all the way up to 3. And so this point you can see is not going to move, but this point here also gets multiplied by 3, so it's going to get bumped down to -3. And then the last point again doesn't move. So you can see it kind of stretches it in a vertical sense. Now, is it always going to do that? Well, let's take a look at another example here in a second after I draw this in. All right, so yes, a equals 3 does cause the largest value of sine to be 3 and the smallest one to be -3, but we don't really care about that one. We just care about the largest one. So in general terms, we can say that the amplitude of y equals a sine of x and y equals a cosine of x represents half the distance between the maximum and minimum values of the function, and is given by the amplitude equals the absolute value of a. So very important to know that the amplitude should always be a positive number, never a negative number. So that's why that absolute value is so important. Now, depending on the value of a, the graphs might be altered by a vertical stretch or a vertical shrink. So we already saw that when a was 3, it stretched it out. But how are we going to get a vertical shrink? And you can probably see that when we have a fraction in front, now it's going to have to be smaller than 1. So that's going to make it more obvious, I guess. Let's take a look. So when we have cosine, now again, be careful. We're not always graphing sine. We sometimes graph cosine. So let's just quickly graph these. So now, instead of starting at 1, because there's a quarter in here, we know that the highest value should be a quarter and that the lowest should be a quarter. The x values don't change. We'll be tackling that later. So we've accounted for the amplitude being 1/4. So that's fine. Everything else is okay. So we just have to draw on our 5 key points. So 1, 2, 3, 4, and 5. So it looks very much the same. That's the one thing you're going to notice in the sections, that The graphs are going to look pretty much the same from one drawing to the next. The only thing that's going to change is maybe your Y scale, so you might be going smaller or larger depending on what your amplitude is. And also your X values might change as well. We're going to see when that changes in probably the next video. So let's do the next one, and that will conclude this video. So we have y equals the -4 cosine of x. So now all of those y values are multiplied by a -4. So what do you think is going to happen now? Our amplitude in this case is 4. Remember, because we have to take the absolute value of that. So we got 4 and -4. Our x values are still the same. And so now, instead of starting up here though, we're going to have to start down here. Because it's multiplied by -4, all of our y values get flipped. So the whole graph gets flipped. And we kind of knew this already. If we remember back to the translations back in chapter 1, I think it was chapter 1, we learned about all those different translations, and reflections. And so when we negate the entire function, we know that that's a reflection in the x-axis, and the same thing applies here. So we can sketch in our curve, and there is our graph. So since we have it as a reflection in the x-axis, we knew it already applied. So that will wrap up this video. We'll pick up more on the periods in the next video. See you in a moment.